Okay, today we get to start a new chapter in our lives, again. So this section's more, this chapter is talking about, finances and loans and mortgages of, on houses and things like that. So this is probably a pretty useful chapter to go over. But, first things first, we got to kind of go over the basics. And I think once we go over the basics, things will make a lot more sense. But okay, well, this section we're combining two into one. The first section is very simple. We're just going to talk about percent. So you probably already know this, but there are, I guess, three different things we're going to talk about as far as percent goes. We got an actual percent. For example, just a simple one, 20%. I don't know, like if you go to a sale at a store, they say, oh, everything's 20% off, something like that. And then there's the fraction form of it. Let's see, example. And remember that a percent is always out of 100, right? What's the biggest percent you can have? It's 100. So if you want to make it a fraction, you can always just put the percentage over 100 and then reduce, I guess, of course. But that would be 1/5. So that'd be the fraction form. And then there's also one more thing that we need to consider is the decimal form of the percent. So the decimal form of a percent, it's like if you're familiar with percents, like if you want to find 20% of something, you multiply that number by 0.20. So that's like, what would you multiply by to find 20% of something? But if you want to memorize it, you just move the decimal twice to the left. Because, yeah, we had 20%, and 20 as a whole number has kind of an invisible decimal point at the very right side after the 0. So I move it once, twice, so it's right in front of the 2. That's the main thing in this section, is kind of trying to be able to go back and forth between these things. Like if you have the fraction form of the percent, can you go to the percent? Or if you have the decimal, can you get to the fraction? So we've got a few ways to go here. So first of all, to change a fraction to a percent, all you do is divide the numerator by the denominator to obtain a decimal number. So that's what would happen if you did, where is it? The example we just showed, we got the fraction 20 over 100, or we reduced it to 1/5. If you take the numerator and divide it by the denominator, 1 divided by 5, not 5 divided by 1, 1 divided by 5, you're going to get 0.20, like the decimal form here shows. And then you can either think of it, like we said before, I was moving the decimal twice to the left, moving the decimal twice to the right, or you could say, like they do in the directions here, multiply the result by 100. And then, of course, add a percent sign, because we're trying to get to a percent. So yeah, it's up to you. You're going to divide the numerator by the denominator for sure. But then after that, it's up to you if you want to say, oh, I just moved the decimal twice, or I multiply by 100. That's kind of however you want to think of it, whatever makes more sense to you. And then what else? Then we also might want to know how to change a decimal number to a percent. That's pretty simple. That's actually what we did halfway through the last one, right? Because in the last one, we changed a fraction. We started with the fraction, yeah, and we changed it to a decimal. And then we changed that to a percent. So it's kind of like halfway in the middle. What we did was we just multiplied the number by 100, and that's it. Or you move the decimal twice to the right. So however you want to think of it. And the last thing we might want to do as far as percents go, change a percent to a decimal. So you just do the opposite. We're going to remove the percent symbol, because we're starting with a percent, and then divide the number by 100. Or you know what, for me, I think I just like to move the decimal twice, just as long as you remember which direction. So the top one, the yellow highlighted part, move the decimal twice to the right. That's how you would get from a decimal to a percent. But if you want to go from a percent to a decimal, move the decimal twice to the left. Yeah, easy peasy. Is that right? Wait, yeah, okay. Just make sure I did that right. Yeah, so instead of multiplying by 100 or dividing by 100, you can just think of it that way. So there'll be quite a few problems like that where we're doing one or more of those things. But something that might be a little new that you haven't seen before, percent change. So percent change, that's the percent increase or decrease, or the percent change over a period of time. It's determined by this formula. So it's, I guess, like stock markets, maybe you might want to know that. What percent change did it, did it increase by 5%? Did it decrease by 37%? whatever it is. So you might see that there, or I don't know, I guess there's probably other applications, but stock market's kind of what I'm thinking of. And then percent markup or markdown, that's probably more like the price of an item at the store or something like that. So let's see, how do you find that? It's the selling price minus the dealer's cost divided by the dealer's cost. Oops, sorry, I should have put a space between dealers and cost. Oh well. And then multiplied by 100. Okay, so those formulas you don't really need to memorize. You can just kind of, I don't know, as long as you know how to use them, that's the main thing. You can write them on your little note card for the exam if you want. That might be helpful, but yeah, not too bad. So if we come to a problem where they want to know the percent change or the percent markup or markdown, we'll just kind of scroll back up and look at this formula, plug things in, bada bing, bada boom. Not too crazy. Alright, let's just jump into it, I guess. Example 1, they want us to change the number to a percent. And we're starting with a fraction. So remember, we said above, how to change it to a percent is you divide the denominator into the numerator, not the other way around. So I think the natural thing is you're going to want to divide the smaller number into the larger number. But it's actually always the denominator into the numerator, no matter if the denominator is larger or smaller. It doesn't matter. So we'll try that. Let's see. And then you can use a calculator, or if you're like me and you're too lazy to get up and get your calculator, you can do long division. So let's see. 17 goes into 20. Oh, sorry. See, I did it backwards, just like I said I shouldn't. 20 into 17. Hello. Well, let's see. 20 can't go into 17, so I have to put a decimal and add a 0. Okay. 20 can go into 170 8 times, because 8 times 20 is 160. If I subtract, what am I left with? 10. If I bring down another 0, 20 goes into 100 5 times. There we go. Okay, so we get to 0.85. But remember, that's the decimal form of the percent. So we need to change it to a percent by moving the decimal twice to the right. Now it's 85% with the decimal on the right side. But you probably know that if you have a decimal on the very right of a number, you can drop the decimal. You only need a decimal point if there's some number or some digit to the right of the decimal, like we had when it was in decimal form. But now that it's 85 and then decimal, it's not really necessary. It's kind of silly to leave it there. So okay, let's see this guy. And this one, I think this is it's not going to be a pretty answer probably. So in the directions, I forgot to say, it says express your answer to the nearest tenth of a percent. So a tenth would be like if you had 15.7%. 7 is in the tenths place. So we'll round to that place. We'll do the same thing. We're going to divide the denominator into the numerator. How many times does 11 go into 30? That would be only twice, right? And then 2 times 11 is 22. If we subtract those guys, we're left with 8. Okay. And then we'll see. We'll bring down another 0. Yeah, and this is kind of tricky because you got to know, excuse me, when to stop dividing and start rounding. So we'll go a little further and talk about it. How many times does 11 go into 80? I just got to guess. Let's see I think 11 times 7 is 77, but 11 times 8 is too big, so I'm going to go 7. Okay. If I subtract, I'm left with 3. Alright, and right now I might be thinking, okay, I can probably stop, right? Because this is in the tenths place, so the 7 would round the 2 up to a 3. But you got to remember that when we change this back to a percent, we're going to be moving the decimal twice to the right, remember? So we're going to have to, let's see. So imagine if once we move the decimal, it'll be here. So we actually need 2 more spaces because this will be the tenths place. But we'll need 1 more spot in the hundredths place to know whether to round the tenths place up or leave it the same. So we're going to actually need 2 more digits after that. Yeah, because imagine it's going to be 27 point something something. Once we get those 2 digits, and that last one will maybe round the last one up. Or sorry, round the previous one up or down. So we got to keep going. I have 30. I'm dividing 11 into 30 at this point. It goes in only twice because 11 times 2 is 22. If I subtract, I'm left with 8. Okay, getting there. Let me bring down a 0. 11 into 80, I think we already did this. It's 7, right? 77. And I guess at this point, I can just say, who cares? Because we have all the digits we need. That's 20, the decimal form, 0.2727 decimal. So you have to go through the decimal to get to the percent. So we're going to go percent. And like we discussed, we're going to be moving the decimal twice to the right. So it'll be 27.27%, but they want us to round to the tenths. And you don't have to write all this out. This can all be just going on in your brain, you know. But the answer is going to be, okay, the 7 rounds the 2 up here to a 3. So it's 27.3%. Beautiful. All right. Let's try part C. Now, they want us to do the same thing. They want us to go to a percent, but this time we're starting with a decimal. So it's going to be a little easier because we don't have to divide any denominators into numerators. All we have to do is move the decimal point twice to the right, or multiply by 100, whatever you want to think of it as. Twice to the right. Yeah, not so bad. So if you move this guy twice to the right, let's see, it starts out here. If you move it once, it goes to the right of the 9. But if you move it twice, it goes an extra place past the 9. So if you ever have an empty space because you move the decimal, you know, more than you needed, or not more than you needed, but past the last digit, you're going to add a 0. So it must be 90%. Okay, let's try to do that with part D. We're going to move this decimal twice to the right. That'll move it directly between the 3 and the 5, so it must be 3.57%. But they did say to round these to the nearest tenths place. So let's see, the 7 would round the 5 up to 6. Looks like we have 3.6%. Beautiful. Alright. So far so good, I think. And then example 2, what do we got? They want us to convert the following percents to decimal numbers. So remember, that's you're just moving the decimal the opposite way, to the left. Move, or dividing by 100, however you want to think of it. Decimal twice to the left. Okay, so right now it's 2 and then decimal percent. Yeah, because even though in part A I don't see a decimal point, any whole number has a decimal, kind of an invisible decimal to the right of the last digit. So it's 2 decimal percent. If I move the decimal twice to the left, it gives me kind of an empty space. So I'm going to put a 0 there. So it's 0.02. Oh, sorry, no percent anymore, sorry. Just a decimal, 0.02. And you know, it's up to your taste. I always put a 0 before the decimal, but you don't have to. You could just do 0.02. I don't know, I think, if I remember back in whenever, elementary school, my teacher said a 0 in front is nice because then you always see the decimal. Because you would never, otherwise you would never see 2 zeros next to each other, right? Like here. That would kind of be a red flag. Why are those zeros next to each other? Oh yeah, there must be a decimal inside. But this guy, you might, I don't know, if it's a, you might not see the decimal or something. But yeah, it's totally up to you. As long as you see the decimal, you're good. So let's try the next guy. The next guy, we're going to do the same thing. Although this guy starts out with a decimal, we're going to move it twice to the left, which makes it a really small number. We're going to have to insert our own 0. 0.0, there was already a 0, 8. Because we moved the decimal past the left digit. So that one's good. Let's try this guy. 41.72%. We're just going to move the decimal twice to the left, which puts it right in front of the 4. There we go. Perfect. So that one was pretty easy. Oh yeah, but to this one, do they want us to round? No, they didn't say round. Alright. Sorry, we're good. Oh, this one's tricky, so they want this one to be a decimal, right? You know what? We're going to have to divide. Dang it. Because 3/8%, that's the same as some decimal percent, you know? Decimal percent. They're just trying to make it easy or harder on us by making it a fraction. So I'm going to first change the fraction to a decimal. Then move the decimal twice to the left, like we discussed. Okay, so what do we have here? 3/8. Okay, I have to divide the denominator into the numerator, so it's going to be 8 dividing into 3. And of course 8 doesn't go into 3, so I'm going to put a decimal and a 0. 8 can go into 30, let's see, 3 times. Because 8 times 3 is 24. See if I bring a 0 down. 8 into 60 is 7. Because 7 times 8 is 56. Oh, I'm running out of room. If I subtract those guys, I'm left with a 4. Alright, this is going to be the end of it, because I know 8 goes into 45 times. So there it is, evenly. So it must be 0.375%. But even though there's a decimal there, that's still just the percent form. Sorry. So we still, yeah, we changed the fraction to a decimal, but it's still technically in percent form. So we need to move the decimal twice to the left to really make it a decimal form. So if I move it once, it moves it right in front of the 0. But if I move it twice, that forces me to add an extra 0. So I think that works. Let me see. How I moved it twice, right? And it started out there. Oh, wait. Oh, no, sorry. I put too many zeros. Oops. Sorry, you guys. Sorry, in the background, you keep seeing... This is my picture of my newborn. So if you're thinking, what the heck is all that skin? Here, let's see. Okay, yeah. I was trying to grab the eraser. Sometimes this program OneNote is a pain in the you know what. I don't want that extra 0. There it is. Alright. Sorry, my voice is terrible. Sorry you have to sit through that. And alright, now what? Now, what are we doing? Example 3. Now that's more exciting. The U.S. Department of Agriculture's recommended daily allowance of potassium for adults, okay, is 3,500 milligrams. Okay. One serving of Cheerios provides 95 milligrams of potassium. What percent of the USRDA of potassium does one serving of Cheerios provide? There might be a few ways to do it, but I think they're giving us numbers that can give us a fraction. Because one serving of Cheerios gives you 95 milligrams out of a total of 3,500 milligrams. So I think once you make it a fraction, then we can change it to a percent like we did before. Although, as you remember, you have to change it to a decimal first. That's kind of the intermediate step by dividing the denominator into the numerator. And then we'll change that to a percent. Let's see. So yeah, I guess feel free to use a calculator, huh? Alright, I'm gonna use a calculator. Don't be a hero. Okay, I got let's see. 0.02714,286. Alright, so there's the decimal form. If I want to change it to a percent, it's confusing because we were moving things to the left just now, but if you want to go back to a percent, you'd move it to the right. So that's 2.714286%. I guess, they didn't tell us to round, so I'll just leave it. But I think you could just pretty much say that's 2.7%. So yeah, I guess a bowl of Cheerios isn't really as much potassium as you need each day, huh? Not quite, not even close. Isn't it bananas that you want? I don't know, whatever. Anyway, example 4. I think you get an insight into my brain because all these examples have to do with food. And that's what I'm always thinking about, so. What do we got? One serving of original Triscuit crackers contains 4 grams of fat. Reduced fat Triscuit crackers contains 37.5% less fat than original Triscuit crackers. How many grams of fat does one serving of reduced fat contain? So I guess what we're looking for is the reduced fat. They said it contains 37.5% of the fat of the original guys, which means you want 37.5% of, they told us that there were 4 grams, right? Yeah, 4 grams of fat. So it really comes down to what is 37.5% of 4. And then in the directions of this section, they didn't really tell us how to find the percent of a number, but I guess they assume that we know that from previous math classes. So in order to find a percent of a number, you change the percent to decimal form and multiply it by the number you're trying to take the percent of. Okay, so we're going to say that's 0.375 and multiply that by what we're trying to take the percent of, 4. There we go. Alright, and then don't judge me if I use a calculator. 0.375. I got 1.5 grams. And I guess that does sound about right. Because if the original had 4 grams, 37.5% of that, I guess 1.5 sounds about right. In reduced fat Triscuits. But I guarantee reduced fat Triscuits taste like poopy. So I don't know. Is it worth it? No, Triscuits aren't that exciting either way, are they? Eh. Oh well. Anyway, why am I getting off topic? How'd you guys let me do that? Alright, what are we doing? Example 5. This sounds more interesting. The population of the United States has been increasing since 1990. Huh, so does that mean before 1990 it wasn't increasing? It's kind of hard to believe, huh? Anyway, in 1990 the population of the United States was about 249 million people. I'm gonna try to remember that. Okay, 1990, population was 249 million. Alright. And then in 2014, it must be something else. Okay. What is it going to be? It was about 317 million. 317 million. Okay. Good times, good times. Determine the percent increase in the U.S. population during this time period. Alright. And you know, if you're wondering right now, should I write that number out? The 249 million, should you write 249,000,000? I mean, you don't have to. You can if you want, as long as you make everything in millions with the zeros. Or you could just leave the numbers as is, like 249 and the other number 317, and just keep in mind that your answers are going to be in millions. That's all. So as long as you're consistent, you know, either everything has the extra zeros to tell it's a million, or just don't put the extra zeros and remember that it's millions. Okay, but here's the formula. The percent change, it's the amount in the latest period subtracted the amount in the previous period. So that must be, we're going to do the latest period was the year 2014, and then the amount in the previous period must be the 1991, and then the amount in the previous period we're going to put, I'm just writing the years, I'm not saying that's what we're putting in the formula. That's the population. So we're going to say the population in 2014 here, population in 1990 here, and the same thing in the denominator. Alright, so it looks like that's going to be what we're doing. So it's going to be population in the most recent year minus the population in the previous time period we were talking about over the same thing we just wrote, population in 1990. Once we get that, it's going to be a decimal number, so we'll multiply it by 100% to get a percent. Yeah, but the formula, just to remind us, it's the amount in the latest period. I guess in that, time-wise, that means the most recent year. And then here the amount in the, what do we say? The past period? I forget what it was. You know, the oldest one. And then times 100% over the amount in past period. Alright, I think that sounds good. So what do we say? The population in 2014, I'm just going to leave it as 317. You could write, like we said, 317,000,000, or just leave it as 317. And then 249 was the population in 1990. And if you put the zeros, you're going to get the same answer, as long as you're consistent. And then the same thing in the denominator. Okay, and you can just do this all at once, but maybe I'll be careful and just write out the steps. Let's see, okay, 317 minus 249 is 68. 68 divided by 249, we gotta divide those guys. What are we gonna get? Divided by 249. It's 0.27. Oh. It's about 0.27. Then what? 0.27309237. Alright, now we're multiplying that by 100, which will just move the decimal to the right twice. So it's 27.309237%. There we go. And did they say to round? If they told me to round, I would, but if they didn't say to round, just leave it. But just know that's about 27%, huh? Just about. Okay. Let's see. So let's try the next one. Oops. Why do I keep... Okay, a Kirby vacuum cleaner dealership sold 430 units in 2015 and 407 units in 2016. Okay. First they want us to find the percent increase or decrease. Okay, let's see. So they said in 2015 they sold 430 units. In 2016 they sold 407 units. Alright, so that'll go into the formula. Alright, I might as well do that first, huh? Let's see. So the amount, percent increase, okay, it was, where's the amount in the oldest period, or sorry, not the oldest, the newest period, 430. Yeah, just kind of referring back to that last problem. The amount in the latest period, the latest is the newest year. Oh, dang it, the newest year was 407, sorry. Minus the amount in the oldest period, 430, over the amount in the oldest period, again 430 times 100. So of course, these two numbers are always going to be the same because they're the exact same value. So let me see here. And notice that if you kind of think about it, this is going to be a negative number because you're subtracting a larger number from a smaller number in the numerator. But it makes sense that we're going to have a negative because the number of vacuum cleaners are, the number of units sold is decreasing from year to year. So of course you're going to get a negative. That makes sense. 407 minus 430, that's going to be negative 23 over 430. So I'll divide those next. What's negative 23 divided by 430? It's negative 0.05348,837. I really wish they would have told us to round, huh? Times 100 will move the decimal twice to the right, so it'll be negative 5.348837%. Alright, so yeah, if you get a negative percent on these problems, don't be surprised. Just, I guess, check to make sure that the amount's actually decreasing. That's all. As long as it's decreasing, then you must have done it right. Okay, now I remember that there was a part B. If the Kirby dealership pays $320 for each unit and sells a unit for blah blah blah, what is the percent markup? Okay, that was the other formula at the top of the page, huh, that I didn't use yet. Okay, where is that guy? The selling price, here he is in the green highlight. Selling price minus, it looks a lot like the old one. Dealer's cost over dealer's cost. Okay, try to remember that so I can copy it down here. Let's see, okay, so it's the selling price minus the dealer's cost over the dealer's cost times 100%. Alright. Not too shabby. So what was the selling price? What did they say? And sells and what was the percent markup? Well, the selling price. Did they say the selling price? Oh yeah, $6.99. Hello. That's how much they're selling it for. The dealer's cost was $3.20. Wow. That's a good markup, huh? And then the same thing goes in the numerator and denominator there. The dealer's cost is twice. And then times 100%. Let's see. So I'll subtract first. $6.99 minus $3.20. It's going to be $3.79. And we're dividing that by $3.20 and then multiplying by 100%, and that'll give it to us. So let's divide $3.79 by $3.20. I've got 1.184375. We're going to multiply that by 100%. Okay, that moves the decimal twice to the right. So wow, it's 118.4375% markup. So I guess, you know, if it's 100% markup, that means that they're taking in twice as much as they bought the stuff for. So I guess it's like if they bought something for $100, they sold it for $200. That would be 100% markup. So they're making, every time they sell a unit, they're making more than twice as much as they bought it for. That's pretty impressive right there. Wow, I guess that's probably more typical than we realize, huh? All right, what are we doing now? So the next section, I just kind of shoved two sections together because, I don't know, that last section was so simple. I just thought, might as well put them together. And I think both of these things you've seen before. So simple interest, I think you've seen this formula before, probably in algebra, as an application of some algebra. But let's see, this section is personal loans and simple interest. This is pretty useful in real life. The amount the bank or lender is willing to lend you is called the amount of credit, or the principal of the loan. Okay, the amount of credit and the interest rate you may obtain depend on the assurance that you give the lender that you will be able to repay the loan. Okay, and that usually has to do with your credit score and all kinds of other things too. And sometimes they even ask for how much you make each year and all, they get really personal. But they just want to make sure that you'd be able to pay it back in the amount of time that they're going to put in the contract. Let's see, then security, and this is something you don't see as much, or as often, I don't think. Security is anything of value pledged by the borrower that the lender may sell or keep if the borrower does not repay the loan in the allotted time. So it's like yeah, it could be a business, mortgage on a property, a title to an automobile, a savings account. So I guess these are things where someone would say, you know what, I need this loan so bad that I'm going to say, you know what, if I don't pay it back, you can have my business, or you can have this mortgage on my property, or my car, or the savings account that I have. So I guess you got to be pretty, I don't know, you got to be pretty sure that you're going to be able to pay it back. But that's what a security is. You probably see that more like at I don't know, like a pawn shop or something, right? I don't know where else you'd see that. I don't think banks do that very much. Well, maybe a mortgage, huh? Yeah, they might. Okay. Let's see it. Then a cosigner. That one you've probably heard of before. It's a person other than the borrower who guarantees that the loan will be paid. So, for example, I think I needed a cosigner when I bought my first car because I had no credit. So, like I went to go buy a car and they said, you have zero credit because, you're 18 years old or however old I was. So we need a cosigner, someone that has good credit to kind of assure that you'll actually pay the loan back. And if you don't, then this person will. So, okay, that's kind of the idea. And then the document they must sign is called the personal note. So it's just kind of everybody agreeing to the same thing. Like, this is the amount of time that the loan should be paid off in, and this is the interest that you might pay. Speaking of interest, interest is the money that the borrower pays for the use of the lender's money. Yeah, most lenders won't just let you borrow money and then you pay that exact amount back in a year or whatever it is. Usually they want, I don't know, some compensation for letting you have that money, right? So we'll talk more about interest in the next section as well, but simple interest is what we'll talk about in this section. It's a type of interest that is based on the entire amount of the loan for the total period of the loan. So there are other types of loans where, as you're paying it off, let's say you make monthly payments, then the interest that's accrued is accrued only on the new amount that you owe. Because if I make a payment, then I owe less. So the interest that I'm paying should only be applied to the, the smaller amount that I still owe. But simple interest is probably not a great deal. You probably don't want to see that because, the interest is accrued on the original amount of the loan, no matter how much you've paid off so far, until you've paid the whole thing off. Let's see, the formula used to find the interest is I equals PRT. So I, of course, for interest, P is principal, which is, the amount of the loan originally. R is the rate in decimal form. And then time is in fractions of a year. It's either a year or fractions of a year. Okay, so keep that in mind. I think it's easy to forget that the rate has to be in a percent in decimal form. Whoops, keep doing that. Yeah. So like if they said, oh, the interest rate is 4%, you're not going to put a 4 here, you're going to put a 0.04. And then time, if they said like 5 months, you'd have to put 5 months out of 12 because it has to be a fraction out of a year. Something like that. Let's see, so I think the more of these we do, the easier it'll get. Let's see, this example, use the simple interest formula above to find the missing value. So we know principal is 800, the interest rate is 4%, time is what we don't know, and interest is 64. So all we do is I'm going to grab that formula. It was I equals PRT, and then fill in what we know. We do know that. That's 64. I could put 0.00, but it seems kind of silly, right? I'm just going to put 64. And then P, principal, is 800. R, the interest rate is 4%, but remember you're putting the decimal form of that. So I'd take 4, which has an invisible decimal to the right, and move the decimal point twice to the left to get the 0.04. And it looks like time is what we don't know. Alright, so I think we're going to have to do a little algebra here to solve this. Solve with algebra. It's going to be 64 is, okay, 800 times, okay, it's 32. And then times t, of course. And if we solve this for t, since t is being multiplied by 32, I'll do the opposite to both sides and divide. 4t. Alright, and actually that goes in twice evenly, huh? So it looks like t is 2, and remember we said time is always in years, so it must be 2 years. Okay, now let's try the next one. Same thing, we're just going to set up the formula, I equals PRT, and fill in what we know. I, we do know, they said that's 343.20, I guess. A principal is, yeah, we know that, 1650. I don't really need to put the decimal in the zeros. R we don't know, but time we do know, 6.5 years. So I'll solve this for R. Solve for R, but I might as well multiply these guys together first. 1650 times 6.5, excuse me, is 10,725 times the R that we haven't talked about yet. Okay, and I can solve this for R by dividing both sides, just like the last example, by the number in front of the variable. Alright, so that's going to be R. Let me see, that's going to be, what is it, 343.20 divided by 10,725. That's 0.032. But remember that the R is in decimal form. So if you want it to be a percent, because you know when you talk about interest rate, usually there's a percent associated with it. I'm going to move the decimal twice to the right. Once, twice, so that'll make it 3.2%. That sounds like a typical interest rate too. Usually it's single digits. I mean, if you see like a 10% or 15%, I guess that's normal, but I don't know, if you see single digits, that's probably a good sign that you probably did something right. Alright, now we're going to learn about Karen. What's Karen doing here? Karen borrowed $3,500 from a bank for 6 months. Okay, so I guess right away I'm going to say she borrowed that much. That means that's the principal. $3,500. And then 6 months is the time. 6 months. But remember, you want it to be in years or fractions of a year. So that's half a year. So I'm not going to, if I have to use this formula, I'm not going to put a 6 there, because that would be wrong. It has to be a fraction of a year. So half a year, or you could have done 6 out of 12 months, of course, but that reduces to a half, so either way you get the right thing. Her friend, Miss Harris, was co-signer of Karen's personal note. The bank collected 7.5% simple interest. Okay, so there's the interest rate. 7.5%. And you know what? It's kind of hard to have a percent where part of it's a fraction, you know, like 7, that's a whole number, but half is a fraction. So you might want to go, that's 7.5%, you know, change the fraction to a decimal and then think of it that way. That's a lot easier. Okay, so they wanted us to determine the amount that she repaid to the bank on the date of the loan. Wait, is that what they asked for? Oh no, sorry, part A. How much did Karen pay for the use of the money? Well, I think they just want to make sure that we know that's interest. So we're going to use the formula, is PRT. P is, what did we say it was again? 3,500. Okay, let's see, 3,500. And then the interest rate we said was 7.5%, but remember we have to change that to a decimal. So I'm moving the decimal of 7.5 to the left twice, so it becomes 0.075. And then the time, I was thinking of putting 6 months, but I got to remember that it's a half. It's half of a year. So that's more like it. Okay, I think if I multiply all those guys together, then I'm going to have the right answer. And if you want, it could be easier to make this half a 0.5. 0.5 there, 0.075, you know, if you want, but it should work either way. Let's try this. 3,500 times 0.075 times 0.5. That's 131.25. Okay, so she must have paid that much in interest. And that was part A. So I guess that sounds about right. That doesn't sound like an outlandish number, I guess. Part B, determine the amount that she repaid to the bank on the date of the note. So that, I think they just kind of want us to use logic. When you repay a loan, you're going to be paying back the principal, because that's how much you borrowed, plus you're paying interest. So I think that's all they want, is just saying, what was the original amount she loaned out, or sorry, that she was loaned, $3,500, plus how much interest was there? 131.25. Alright, I think that's it. So that would be 3631.25. Okay, that's, I guess, not too bad. Good stuff. All right, I think we're doing good here. All right, third example. Jeffrey wants to take his mother out to dinner on her birthday, so he pawns his watch. Oh, that's sad. Or, I mean, kind of sweet too, right? It's kind of sad and kind of sweet at the same time. The pawnbroker loans Jeffrey $75. 14 days later, Jeffrey gets his watch back by paying the pawnbroker $80.25. What annual simple interest rate did the pawnbroker charge Jeffrey? Okay, so I guess what we're looking for is R. We don't know the interest rate. I imagine since there's only one formula in this section, it's probably going to be this formula, right? Just got to fill in what we know, and I'm assuming R is what will be left over. So I'm going to try to figure out what's I, what's P, and what's T. Okay, interest. Did they tell us that? So he was given $75. That was a loan. So this is kind of tricky because the principal was $75, but he paid back 80.25. So if you think about it, he paid back the principal plus the interest. So if $70 of that was principal, the rest must be interest. Interest is the principal, or sorry, the amount that he paid back minus the principal. Right? Because what he paid back was not only the principal, but the interest as well. So the leftover, once you take away the principal, must be the interest that he paid, $5.25. Alright, so this is, sometimes you have to use a little logic, and it's not just really cut and dry, and they don't just give you everything that you need. You're going to have to think about it. So, okay, the interest was $5.25, and we already said the principal was $75, because that's how much you got from the loan. The rate we don't know. Time is kind of tricky, because they said it's 14 days. But you want it to be in a fraction of a year. So how do you write 14 days as a fraction? Well, 14 days out of 365? Or you know what, I guess you could do is say 14 days, if you want to make it simpler, is 2 weeks. So you have 2 weeks out of 52 weeks in a year. You can do it that way as well, but it shouldn't matter either way. I'm just going to make this into a decimal anyway. Yeah, that's going to make it a lot easier. Okay. Let's see here. What do we got? I'm going to try to get my calculator. First I'll make that a decimal by dividing 14 by 365. So that's, let's see, here, this guy, leave it the same. This guy, leave it the same, but this I'm getting 0.038356, somewhere in that vicinity. And then I'm going to multiply the 75 by that guy, just so we only have one number in front of R, times 75. So it's 2.87671233R. Okay, and then lastly, to solve for R, we just need to divide by that number on both sides. 2.87671233 on both sides. Alright, so R is going to be whatever that ends up being. Let me see. 5.25 divided by 2.87671233. So I'm getting 1.825. Alright, and remember that you're getting a percent in decimal form, so we have to move the decimal to the right twice still. So it's 182.5%. Wow. That's a high interest rate. And if you think, wait, that doesn't sound right, that's a really high interest rate. I think it's because of this it's a really short period of time, right? It's only 14 days, but he's still charging this guy $5.25. So that's kind of why I think it seems like a really high interest rate, and it doesn't seem right, but that's why. It's because it's a really short time period. Okay, because it's that per year. So if you think 14 days versus an entire year, okay, it makes sense that would, yeah, because I guess the interest is $5.25. That means every 2 weeks the pawnbroker guy is making $5.25 off this guy. So I guess if you say, well, every 2 weeks, how many times is that a year? That's 26 times a year. So if he makes $5.25 26 times over a year, he's gonna more than make up that money. So I think it does kind of make sense, just only because it's such a short time period. All right, sorry, we're on the last one here. I'm kind of sad. Hope you guys aren't too sad. Let's see, on April 3rd, the Mears Flag Company borrowed $15,000 to pay for startup costs for his new showroom. Okay, the loan had a simple interest rate of, okay, so R is going to be that. And it was for 270 days. Okay, so that means time is that, but that's in days, so we're going to put that over 375. And I guess the amount borrowed is the principal, right? 15,000. All right, the company was able to make partial payments of 6,000. Ooh, okay, so this is something that is new. $6,000 partial payment. What is it? On May 28th. Okay, and then he made another payment, $3,500, on October 12th. How much will the company owe on the date of maturation? So that's the date that the loan is due. Due date. Okay. So what do we say? Oh, okay, it's for 270 days. All right. Okay. So let's see. I think what we have to do is figure out the interest for each time period. So we have to think. So he took the loan out on April 3rd, but then he made a payment. When was the first payment? May 28th, I think. May 28th. Okay, so we'll think about that. Okay, interest is principal times rate times time. Okay, and at that time, in that time period, he hadn't made a payment yet. So the principal is still the original amount, 15,000. And the rate is, they said 8.25%, but in decimal form, that's 0.0825. And then the time was 270 over 375 as a fraction. All right, I'm probably going to make this guy a decimal first and then multiply them all together. But I think we'll just do it all real quick. Okay. I got $915, and I guess you want to round to the nearest cent, huh? Why would you have more than that? When I realized that I was saying that there were 375 days in a year, but there's only 365, sorry. Okay, so that's the interest that he was paying. But now, in the next part of this, he has a new principal because he paid off part of it, right? So it was 15,000, but now how much did he pay off? He made a $6,000 partial payment that day, so he has 9,000 left. So that's the thing. He has a new principal now. Yeah. Okay. So I think that's it. Let's see. Then the interest he's paying for this new time period, which I guess it's the end of the previous time period, May 28th till, when did he make another payment? October 12th. Okay. Oh, shoot. You know what? I realized I messed up. I'm sorry. Can I go back? The time, on the last example I did, the time period's wrong. Because this time period here, or this is right, April 3rd to May 28th, but that means the number of days here should be different, right? How many days passed from April 3rd to May 28th? Let's see, well, May has 28 days, or sorry, that's 28 days in May, plus 3 days in April. So you would think 31 days, but you're not going to count this day. I'm not counting May 28th because he made a payment that day. So it's not 28 days in May, it's only 27 days in May that he owed this. 27 plus the 3 would be 30. I'm sorry, this should be 30. Sorry, this is a 30-day period. I'm sorry about that. Let me just do that calculation real quick again. Okay, sorry about that. I'm getting, not this guy. Only 101.71. Sorry. I'm forgetting that it's not the whole time. It's only these individual time periods. Okay. So now I gotta do the same thing with the next time period. From May 28th to October 12th. How many days is that? Let's see. How many days are in May? 31. So the 28th, 29th, 30, 31. So okay, May 28th through the 31st. That's 4 days. What's the next month? June has 30 days. July has 31 days? Wait. Yeah, 31 days. August has 30 days. Wait, no, 31 days. February, March, April, May, June, July. Okay. Dang, this is a long time period, huh? September has 30 days. Okay, and then we're finally in October, which you only want from October 1st to October 12th, and we're not counting the 12th. Because if you make a payment that day, you're not going to count that day against them, right? I made a payment, so don't count that against me. 11 days. Don't count October 12th because a payment was made that day. You're not going to charge me interest on the day I made a payment, right? So these are the number of days total in this time period. What's that? 34, 65, 96, 126, 137, I think. Okay. Okay, so our fraction is going to be 137 out of 365 for time. Principal, rate, time. Principal, now that we said the new principal, since they decreased the amount, since he made a payment on May 28th, the new principal is 9,000. The interest rate, they said, is not changing, so I'm going to leave that. And then the time, we said 137 days out of the year, 365. There it is. So let me see what that'll be. Okay, that's a larger interest rate, or interest. That's I want to round to the nearest dollar. $278.69. Okay. Let's see, I forget now. Was there another rate or no? How much will the company owe on the date of maturation? I think now we actually, this is a complicated problem, huh? Now we have to figure out what the date of maturation was. Let's see, well, what was when did he borrow the money initially? April 3rd, okay. April 3rd, oops, not 30th, 3rd. Day 1. And they said it's a 270-day loan. I have to figure out if April 3rd is day 1, when's the 270th day? Well, we know from day 1, April 3rd, to what was the first day he made a payment? May 28th. I know that was 30 days. And then from May 28th to, let's see, when was the next payment again? October 12th. What did we say that was? 137 days. So on October 12th, how many days had passed? 167 days. Okay, so from October 12th, I just got to figure out from there, when was the 270th day. So I'm going to just look at a calendar and see if October 12th was the 167th day. October 12th is the 167th day, then what is the 270th day? Oh, actually, you know what? I realize it doesn't matter. Sorry. It doesn't. They don't ask for the date, right? Do they? No, they just want to know how much they owe. Okay. So I just got to figure out what's the last period. So from October 12th to the date of maturation, how many days are left over? Was because the entire loan was a 270-day loan, but by the time they made the last payment, 167 days had passed total. So the total minus the number of days that have passed, that's going to be 103. Okay, so the last period was 103 days, and the interest is the principal times the rate times the time, but the principal is going to be smaller again. The new principal is what? Let's see. New principal. Well, remember we said when he made the last payment, the principal was only 9,000, and he made a payment of, how much did they say? He made a payment of 6,000? Oh no, 3,500. Okay. So yeah, second payment was 3,500, so he no longer owes 9,000, he only owes 5,500. So that'll be the new principal. We already paid part of it off. And then the rate, what's the rate again? Where's that? 0.0825. Okay. And then the time, what did we say? Oh yeah, 103 days, but that's out of 375. Or sorry, 365. Why do I keep saying 375? Okay, so that's the last interest he has to pay. So this is tricky. You can see why finances are pretty complicated. But thankfully nowadays, a lot of people that do this for a living, calculate these things, they have computer programs that'll do it for them. That's the nice thing. Alright, for this calculation I'm getting 128.04 if I round it. Okay, so our total interest is the three interests added together. So the first interest plus the second interest plus the third. We just found the third one was 128.04. Let's see, and then what was the previous one? Previous one, did we write that down? Oh yeah, okay. I think those were the three answers we got as the three parts of this problem. So this first interest was from day one to the first payment. The second interest was from the first payment to the second payment. And the third interest was from the second payment to the end of the loan time. So the answer is going to be whatever all these interests added together is. Let's see, I'm going to calculate that now. Alright, I got a total of 505.44. Alright, these problems are really tough. So, you know, if you think, man, this is a tough one, just keep in mind if this was on an exam, you would definitely get a lot of partial credit, which is why it's important to show your work on these problems. Yeah, make sure you show a lot of work, just to make sure that you're getting credit for your work. Just because you don't get the right answer in the end doesn't mean you shouldn't get some partial credit. You know, as long as you had the right idea for the most part, that's what matters. Okay. So, okay, that was fun. Just kidding. Probably not for you guys, but I hope it made some sense, and if not, please let me know, or watch the video again, or look up other videos if you don't like the way I explain it. I know I hate my own voice, so I imagine you guys hate my voice too. Sorry about that. But I'll see you in the next video. I think it'll be even more interesting and more applicable to real life. So thanks for listening.